Hello everyone. In the last video we have seen that how we can select a structural formula with the condition or with the rule. That rule was the x value should be in ascending order. So actually I have done a small mistake over here. So it should be like this, that x1 should be lesser than x2 and x2 should be lesser than x3. So this is a small modification just in this video. Next, after this we will check it that how we can go with the next procedure, that is structural diagram. So in this video we are going to see that how we can draw a structural diagram. Now we have two formulas, that number one, z is equal to 2 in bracket 1 and 3 in bracket 2, and one more formula that we got it, z is equal to 3 in bracket 1 and 2 in bracket 3. So these are two formulas, and of these two formulas, these are the most suitable formulas as per our calculation. So in this formulas, how we can draw with the structural diagram. Now for drawing a structural diagram, we have to draw few lines. So number one, there are two things that we are going to separate. One is horizontal line and second is vertical line. So for horizontal line, how many horizontal lines we should draw it? So we should draw horizontal line which is equal to 6. Now what is that? Which is equal to z. Z is what? Number of speed steps. So we have already calculated z value, that is p1 into p2, and that is equal to 3 into 2, which is equal to 6. So we have to draw 6 horizontal lines, and for vertical lines we know that it is two-stage gearbox. So there will be one input shaft, one output shaft, and one intermediate shaft. So it is simply, while writing in formula, it should be n plus 1. Now here this n stands for number of stages. So total we have 2 stages and plus 1, which is equal to 3. So while drawing it, we have to draw 6 horizontal lines and 3 vertical lines. So let's move further. Now if we'll go with the first formula, z is equal to 2 in bracket 1, 3 in bracket 2. So we will draw first 6 horizontal lines, 1, 2, 3, 4, 5 and 6. Now 3 vertical lines. So this is 1, this is 2 and this is 3. So total we have drawn 6 horizontal lines and 3 vertical lines. Now in this, how we should proceed? Now this first part, 2:1, it denotes stage 1. So this 2:1, 2 in bracket 1, this is the first stage, and this 3 in bracket 2, this deals with the second stage. Now we know we have total 3 shafts, so we will write down shaft number 1, shaft number 2 and shaft number 3. And what about speeds? So speeds, it ranges from here. So first basic is 1, second, third, fourth, fifth, and the last one is 6. So we are going to get the 6 speeds over here, 6 different speeds, and these are 2 stages in it. Now how to draw with the structural formula? Now in this we have to calculate from this one. So what it shows? It shows it that from this first shaft, on the first shaft, we are going to set one point. So we are going to deal with this. So whatever we have value of x, that on first shaft we should have one point, and from that one point, so this is 1 point on shaft 1, and from that one point, next step is there will be 2 lines. So 2 lines, we are going to draw it, and those 2 lines should be having gap of, again, the third point 1. So as per this formula, there should be 1 point on shaft 1. So as it is 6 lines, so its midpoint will be somewhere here, that is 3.5. So we will write it as, suppose, 3.5. So this is the first point. Now through this point we are going to draw two lines, gap of 1. So here we are going to plot second point, here we are going to plot third point. If we'll join it, so it will be the gap of 1, that is 3 and 4. It is a gap of 1, and it fulfills our all condition that there is point on shaft 1 and two lines at the gap of 1. So similarly, if we check for the second stage, it is already mentioned that there should be 2 points, so our answer is right. So there should be 2 points, and on those 2 points, those 2 points are in shaft 2, and from these 2 points, each point, there should be 3 lines at a gap of 2. So first we will concentrate on, suppose, this point, the lower one. So we are going to draw 3 lines from this point at a gap of a 2. So first line, if we'll draw it here, the second line will be somewhere here, and the third line will be somewhere here. So we will join it. So this is done. Similarly, for this point also, it will be this first point, second point, and third point. Just from this diagram, you'll come to know that these are crossing these lines are crossing, but no point is repeated. That on each point we have separate lines, especially on this one. On this we have multiple lines, that is fine, but at the end points we are getting only one speed. So this is related to the first structural formula, and we will go with the second structural formula. The second structural formula is this: Z is equal to 3 in bracket 1 and 2 in bracket 3. So again the same thing, we will draw 6 lines and 3 vertical lines. So this is 1, 2, 3, horizontal line 1, 2, 3, 4, 5, and 6. So in this, again we will start with this. Now this is our shaft 1, this is our shaft 2, and this is our shaft 3. And in this we have the first stage, that is 3 in bracket 1, and second stage 2 in bracket 3. The similar points, we will start with it. The first one, that there will be 1 point on this. So we will write down the speeds also: 1, 2, 3, 4, 5, and 6. Now in this there will be 1 point, so there will be 1 point at the middle, that is at the level of 3.5, and from that 1 point we are going to draw 3 lines. So again, as it is at the midpoint, so draw here, this is our 1 point, and at a distance of 1 again. So at a distance of 1, this and this, here we will get at the midpoint, we will join the line. And from this, the second stage, there will be 3 points on the shaft 2. So there are 3 points on the shaft 2, and from that shaft 2 we are going to draw 2 lines each at a distance of again 3. So from each point we are going to draw 2 lines at a distance of 3. So for this, if we get with the lower point, so for a distance of 3, this is the 1 point and this is the other. So we will join these 2 points. One is finished. Second one, for this point, again here we will be having next point, and then other one will be here. So we can join it. And the last point, this will be one line and this will be other point. So if we check it, if we check for the particular points, the distance is 3 here. Similarly we have followed in each and every point. So if we check, compare with the 2 diagrams, you will come to know the method is same. Now how to select the best structural diagram for this, or for best structural formula from these 2? Now there is a very simple thing that we are going to calculate for node. So the next point we are going to see is, that is node. Now we have done with the structural diagrams. Now in the structural diagrams we are going to check it, the node formula, that from that node summation we are going to select that which diagram is the most suitable. Now for that we have to select the lower speeds. So if we'll compare with the diagram 1, so the lower speed is somewhere here, 1. After that its related load speed, it is here, and next one is this. So if we'll add all those things, so first one, it's node summation, So it will be 1 plus 3 plus 3.5. So it is 7.5. Now for the second diagram, if we check it, the node is, this is the first, this is second, and this is third. So the value related to this, it is 1, this is 2.5, and this is 3.5. So we will add those values. So node summation is equal to 1 plus 2.5 plus 3.5. So it is equal to 7. Now we are going to select the addition which is greater. So in the first case we are having 7.5, and in the second case we are having 7. So we are going to select the first diagram. So the first diagram, the best structural formula is Z is equal to 2 in bracket 1 and 3 in bracket 2. So this is the most suitable and best formula for our problem.